Welcome back. So far in this course, we made ourselves familiar with the AWS Cloud Platform, infrastructure, and its services. In this section, we will do a deep dive into AWS networking and related concepts. But before we jump into AWS networking, let's start with some networking core concepts. In this first lecture, I want to help you conceptualize the following core technologies. Let's start with the network. So, what is a computer network? I hope you already know it, right? A computer network is a group of computers that are connected to each other using a communication protocol. The most commonly used communication protocol is the TCP/IP protocol, right? And this is how a super simple TCP/IP network looks like. You have one or more devices. All of these machines are connected to a bridge or a switch. This is how a typical switch looks like. It comes with many switching ports, and you can insert a network cable into the port. The other side of the cable goes to the device. Every device in the network must have a network card known as NIC, Network Interface Card. This is how a NIC looks like. The NIC card also has a port, and you can insert the other side of the cable into the NIC card. So, one side of the cable goes to the switch, another side of the cable goes to the NIC card of your device. And that's how a wired TCP/IP network is created. All of this can be wireless, but let's assume we are making a wired network. Great. So the physical connection is established. Now we want these computers to communicate with each other. How does that happen? Let's assume this computer wants to send some message to that computer. But addressing computers with this and that is not going to work, right? We must give a unique ID or an address to each computer. So we have two things here, MAC address and IP address. Every NIC card comes with a unique ID that looks like this. This unique ID is known as the MAC address of the network card. Similarly, every NIC card should also be given a unique IP address that looks like this. These two addresses are necessary for the working of a TCP/IP network. So, every NIC card in the TCP/IP network must have these two addresses. The MAC address is pre-assigned by the hardware manufacturer of the NIC card. In a typical case, the MAC address is fixed and we never change it. However, the IP address is not fixed and we must assign an IP address to each device in the network. In a typical TCP/IP network, you will have a DHCP server responsible for assigning a unique IP address to each device. We can assign the DHCP server responsibility to one of the computers in the network. However, your network switch can also take up the role of DHCP server. So, you don't have to waste a PC for doing this. Great. We learned how the TCP/IP network looks and the main components of the TCP/IP network. The first thing is your computer. The second one is the NIC card and its MAC address. The third one is your switch. The fourth item is the DHCP server. And the final one is the IP address. Now, let me elaborate a little on the DHCP server and the IP addresses. The DHCP server will assign a unique IP address to each NIC card in the network. But from where is this IP address coming? I mean, how the DHCP server assigns this address? Will it simply take a random IP address and assign it to one of the devices? No, it cannot take whatever IP address. We must configure the DHCP server giving it a pool of IP addresses. Once assigned, the DHCP server will take one free IP address from the pool and give it to the device. Similarly, other devices in the network will also get a unique IP address from the free pool. The DHCP server keeps track of the devices and their IP addresses. When a device leaves the network, the IP address is taken back and placed in the free pool. Similarly, when the device comes back and joins the network, a new IP address from the free pool is assigned. This new IP address may be the same as earlier or maybe not. The DHCP does not guarantee the same IP address every time. And that's why these IP addresses are known as the dynamic IP address of the host machine. And the DHCP is known as Dynamic Host Configuration Protocol. Make sense? Great. Now let's come to the IP address pool. This pool of IP address is commonly known as the CIDR block, the CIDR block. How does it look? Here are some examples. The first one is the CIDR block of class A address. The second one is CIDR block of class B. And the last one is the CIDR block of class C address. Class A is for a massive IP address pool, and it can accommodate more than 16 million devices. Class B can accommodate more than 65,000 devices, and Class D can be used for 254 IP addresses. The CIDR block address is composed of two parts: network prefix or network ID and host ID bits. I'll explain it in a minute, but let's assume you are setting up a network. You are expecting to connect 30 to 40 devices in your network. You want to configure your DHCP server with a pool of IP addresses. You already know the pool of IP address is defined in terms of a CIDR block. So, how will you choose a CIDR block for your network? Let's try it. I know all I want is to connect 30 to 40 devices. So, I can go for the Class C type of CIDR block. Why? Because that one is enough and it can support up to 254 devices. I want 30 to 40 only. So, I should go to Class C. Make sense? Great. Decided on Class C. What next? Now, I need to decide on the network prefix and the host ID bits. Let's use a tool for doing this. Here it is, subnetcalculator.com. I already decided on Class C, so let me choose Class C here. The IP address range for Class C starts from 192.168.0.1 and goes up to 192.168.0.254. So, I can have up to 254 addresses. But that's too much for me. All I wanted is 30 to 40 addresses. Can I reduce the range? You can. Let me increase the mask bits. Make it 25. Great. Now I can have up to 126 addresses. But that's still too high. Let me increase the mask bit further. Make it 26. Now it looks better. I can have 62 IP addresses. I wanted 30 to 40 addresses, but 60 looks acceptable because I can keep some room for expansion, right? Great. So what is my CIDR block? 192.168.0.1/26. Correct? And what is my IP address range? Here it is. It starts from 192.168.0.1 and goes up to 192.168.0.62. Make sense? Great. But I'm a little curious. Do I need to start my IP address range from 192.168.0.1 and have 62 addresses? Can I start from a different number? It may be started from 192.168.0.25 and take 62 addresses from there. Is it possible? Let me try. Change the starting IP address to 25 and press the tab. Oops, nothing changed. My IP address range is still the same. What does it mean? I can also write my CIDR block like this. It has the same meaning as this. Both are the same and valid CIDR notation. But I still don't want to take the 1 to 62 range of IPs. For some reason, I want a different number. I tried 25 here, but it didn't work. Let me try some higher number. Let's make it 50. No difference. Well, looks like nothing less than 62 will make any difference here. So, let's try 63. Still no difference. Why? Look at this. 63 is the broadcast address of this network. So, you can't even start from 63. Let's try 64. Voila, it worked. I got a new range from 65 to 126 and the broadcast address as 127. I want to use it. So, let me set the CIDR block of my network. Here it is. I have this small TCP/IP network. I have just 3 devices, one switch that also works as a DHCP server, and I assigned a CIDR block of my network. All 3 devices will get one IP address from the CIDR block of this network. Make sense? Great. So we learned the following fundamental concepts of a TCP/IP network. In the following video, I'll take it further and explain to you few more concepts. See you again. Keep learning and keep growing.